Hi, okay, so thank you very much. In addition to my Django stuff, my day job, I'm the CTO and co-founder of a company called TradesCloud. We're a cloud provider of services to tradespeople like plumbers, electricians, that sort of thing. So just as the short plug commercial thing, this is why I'm here from a commercial point of view. And if anyone's interested in migrating to Perth, we are likely to be hiring in the very near future, so come and have a talk. But like I say, that's just my day job. The reason I'm really here is because I'm a core developer on the Django project, have been since January of 2006. I'm president of the Django Software Foundation since mid-2010. And as I said on Monday, the DSF is the IP, legal and fundraising arm of the Django project. And in particular, I'm here today to talk about class-based views. Class-based views were introduced in Django 1.3, which is almost 2 years ago now, but have, shall we say, not been greeted with universal enthusiasm. So I'm here 2 years later to do a bit of a mea culpa and to help clear up the mess. What are they? Why do they exist? And why should anyone in this room or not in this room care? This isn't going to be a tutorial, strictly. It's more of an attempt to set the big picture straight in the hope that if I can seed into the community enough knowledge about what it is we were trying to do, that maybe some of the broader discussions about class-based views will stop making some of the fundamental thing or making so many fundamental mistakes, and maybe we can get on to making the whole thing a lot better, or at least stop being quite so badly wrong. So, if we're talking about a big picture, it helps to explain, in order to explain what we've got, it helps to know where we came from. In the beginning, cast your minds back to the halcyon days of 2005. Django has just been released. It's July. Adrian and Jacob have just pushed a tarball, and it didn't have generic views in it at all. Generic class-based views weren't added until the first public code until July 25th, 2005, revision 304 for those playing Buzzword Bingo. Why were they added? Well, Django is a framework for building websites. Views are for displaying content. And there's a lot of really common patterns in the way that you build these views. We all like being dry. We don't want to repeat ourselves. So refactor all the things. We have generic views. We have a lot of common things we need to do. We need to display a template. We need to display a single object on the page. We need to display a list of objects on a page. We need to display a form that can process in some way your CRUD operations. You need to be able to display an archive of content on a date-based, on a date archive basis. These are all sort of things that have come directly from the CMS-like needs of a journalism organisation circa 2005. The key implementation features, well, every view is a function. And you configure those functions by the arguments that you pass into the function, some of which are coming from the URLs that you're processing and some of which are configuration that are going to be every time that function is called. So start right from the beginning. Here's your stereotypical view to edit a book. It's a function that takes a request and the ID of the book you want to look at. You do a try except to get the book, and if it doesn't exist, raise a 404. If the method is receiving a post, then you construct a form based around that instance. You check if the form is valid, you save the form if it is, and you redirect somewhere useful. And then, of course, you need to, then you've got the other end. If it's not a post, then you need to construct a form that's empty based upon the instance and then render it to the user in some way. And because of the way the if logic flows, if there was an error in the form, then you'll end up rendering the same form but with the errors. Okay, that's all fine and dandy. We've had to run that over 2 slides, so it's lots of code. It'd be great if we could cut that code down to size. We can do that through the URL patterns, essentially. If we were going to deploy our manually created edit book view, we'd have to go to the URL patterns and make a pattern that will capture the book ID, which we're going to pass into the function. We say we're going to call book view, and we'll give it a name so that we can find it easily in templates. So how do we do that in generic views? Well, essentially we say, well, this is just an update object view. Go to generics, get the update object view. It's going to operate on book, so we pass in the fact that we're going to deal with a book model. And because it is based on a model, we can use a generic model form based around that book. Instead of saying a book ID, we use a generic name of object ID, and that will get passed straight into the function, the ID value we pulled out. And the rest of the function will work exactly the same. Essentially, the 2 pages of code you saw before can be replaced by 1 call in and a configuration to say, use this model. So why is that dry? Well, if we want to change to have an update object, update author view, Exactly the same deployment, we just got to change the name to say we're going to look at author, the model we're using is author, and the name of the URL is slightly different. So you change the 3 places where there's actually some difference, or there's actually some configuration that needs to happen to make it specific to author instead of specific to book, and you don't have to write another line of code. Awesome, so why don't we just stick with that? Well, there are some problems. The configuration options are strictly limited by the arguments that are provided by the generic views. Do you want to instantiate a different form rather than just a default model form based upon some sort of property in the object that was being requested? You can't do that. Do you want to perform some logic after the form has been validated but before the form is saved? Well, unless you can work out a way to get it into the form's save method, you're completely out of luck. Do you want to pass in extra arguments to the form when it's instantiated? Like, for example, the request object. Well, that's completely, you're out of luck there too. Do you have some sort of common permissions logic that you want to run? Well, unless you can put it in a decorator on the view, you're out of luck. So you have absolutely no control over the flow of logic inside this function. It is a generic function. It is there, you use it, and that is all you get to do. And unless there is a single drop in a different object, drop in a different function extension point that you can use, then you have to rewrite the function yourself anyway. So there's very limited reuse between the views as well. A create view and an update view are essentially the same thing except for how you're instantiating the object, but you've still got to duplicate. This is on sort of more Django's problem than your problem, but Django internally had to duplicate a whole bunch of code. So how do we address these problems? Well, you could go ahead and just keep adding new arguments and new functional entry points and new configuration arguments to the generic views. Or you can change arguments to allow for callables instead of allowing them to be just objects that are instances that are going to be used. But at some point, you're going to end up basically poorly implementing half the features of class inheritance. So, again, refactor all the things. Let's go class-based. Class-based, the idea behind object orientation, the idea behind using classes is that you get all these options for free. You can use subclasses to override specific pieces of logic, replace pieces of logic, and you can use mix-ins to compose behavior into a larger class, or take different pieces of behavior and compose them into a single class. It's not quite that simple though. As I said, we added class-based views in Django 1.3. The discussion was actively going almost before 1.0 was out the door. The official planning sheet that we had for Django 1.1 said it was going to be in 1.1. And it just didn't quite happen. And then it was a big push, it was going to happen for 1.2, and it didn't quite happen. And then eventually it did happen in 1.3. I did the final commit, but it wasn't only my work by any stretch of the imagination. I was building upon some work that had been done by Ben Fershman. Ben was working on work that had been done by Jacob Kaplan-Moss. Jacob had been building on stuff that had been done by Joseph Cochrane's. There was half a dozen rewrites and rebuilds and restructures that went on along the way. So in 1.3, we finally got all the pieces together. We sorted out all the problems that we saw, and that's where the wheels fell off. Why? Okay, well, there's a couple of reasons. Firstly, there's been a lot of confusion about what class-based views are and what they can be used for. There's 2 very distinct purposes tied into what was a single commit of class-based views. And the fact that we've basically put 2 features in one commit is sort of half the reason why there's been a lot of confusion. The second problem is that the implementation wasn't obvious. Okay, it's necessary, the implementation we have was necessary for some very important reasons, but those reasons aren't necessarily obvious, and there's some complexity unless you understand how the sausage was made, it just looks like needless complexity. The third criticism is something that was a term, I think it was coined by Luke Plant, but if he didn't, I'm sure he'll be happy to give the credit to whoever was due. Luke is one of Django's core developers, so he's not like he's outside the community criticising us, he's in the community and criticising us. He described the class-based views as ravioli code. Ravioli is really just another type of pasta, so what he was trying to get at is that spaghetti code is bad code because you just got this great big mess of swirling spaghetti and you can't see where the logic goes and it's all just a mess. Ravioli, very, very clean, nice, neat parcels, but you don't know what's in the ravioli. And unless if you want to dig in and start making your own ravioli, well, you've got to start grinding up all your ingredients and mixing them together, and then you give someone your bowl of ravioli and they have no idea how on earth they got this stuff inside a nice little neat package. The package is neat, it's easy to explain, but if you want to get involved and deal with any of the internals, you kind of need to know how all the internals work. This means that there's a price to pay to becoming an expert. There's a really steep learning curve, and that learning curve is not sort of an obvious expression of what needs to be done. You need to understand everything before you can do anything. And that's a problem. I completely acknowledge that that is a problem. And that problem was made worse by the documentation. Now, in this case, I have to take full blame for that. I wrote the documentation pretty much from scratch, and I completely missed the mark. Danny and a number of people sprinted on them at one point and made them substantially better. There is still a lot of room for improvement. The fact that we're still having discussions about why class-based views are so awful means we have failed to communicate effectively how to use them properly. And that's something we need to address as a community. Okay, so let's look through these turn in turn and try to clean up this wonderful mess that I made. First off, purpose. Okay, so we have in class-based views, when people are talking about class-based views, there's actually two very distinct things. There are class-based views and there are class-based generic views. One commit, two very distinct features, one of which builds on the other. The class-based views are just providing a framework-level solution to the core problem of how do I use a callable class or a class of some description as a view. It's there to provide method-based HTTP verb dispatch, so you can say, here is my implementation of what I want to do for get, and here is an implementation of what I want to do for post, and so on and so on. And that's it. That's all class-based views are. So, okay, here is a class-based view. You're basically saying, here is a base class that we can extend, and by virtue of extending it, we can define a get, and we can define a post, and we can put a logic for what we want to do in a get and a logic for what we would do in a post, and we can deploy it. And that's all it's trying to do, is provide the infrastructure to let you do that as an end user. But because we're subclassing a base class, we get a whole lot of extra functionality for free. You get automatic options request handling. So if you want to know what HTTP verbs does my view handle, class-based view will give you that for free. It will do an automatic naive head request handling. So essentially, if you make a head request, it will return just the header. It does it the naive way by generating the get and just returning the header part and leaving the body content off. So there is lots of room to optimize it if you want to write your own head method. But it gives you a head method, which a lot of, you won't have by default if you were writing a function-based view. And it gives you an automatic HTTP 405 if you request a verb that isn't available. So if you make a trace request on a generic view that hasn't had trace set up, it's going to fail. You're going to get a HTTP 405. All of these are properties that you don't get out of the box if you just write a function-based view. And as an aside note, you don't get if you have a generic function-based view either. Built on top of that base framework, that base mechanism for rendering a view, and it's not even getting to the point of where do you do the templates or anything like that. It is literally just serving pages. We've built class-based generic views, and this is the second feature. They use Django's new class-based view as a base, and they extend upon it. And they create analogues of all of the old generic functional views. It addresses all the limitations of the old functional approach, because we can now subclass and override specific pieces of functionality or configure specific pieces of functionality in callable ways, or in ways that have complex logic, not just a straight value. The catch is that by addressing all those limitations, there's the whole new body of knowledge you need to know about, how and where you extend. That's the ravioli criticism, and I'll come back to that in a little bit. Okay, so the first criticism we had was our implementation choices. If you go and have a look on Django's wiki, the class-based views are an example of, or a relatively good example of how large features in Django are discussed throughout the whole community. We've got in the habit with a couple of our big changes. Class-based views is one, the messages, adding contrib messages, adding configurable user models is another. there is a lot of discussion, there is a lot of debate, there are a lot of design ideas. And what we've done is we've gone and taken all those ideas and documented them for posterity. And if you go and look at that URL, that class-based views URL in Django's wiki, you will see the full discussion of all the options we looked at and what their strengths are, what their weaknesses are, and why we rejected various ones that we did. And at the bottom is a summary to say, we chose to do this. So if you want to see the full detail of how the sausage was made and what we threw out, go have a look there. But the summary version of it, when someone sits down and says, okay, well, we need to have class-based views. We need to be able to deploy a class as a view. Well, you just have a class, you instantiate it, and it's a view, right? That's easy. Well, what exactly do you mean? Do you mean you're deploying the class? Do you mean you're deploying an instance of the class? Do you mean you're using a class method on the class that can then be used as a view? Or are you calling a factory that produces something that is a view? All of these things can be called class-based views. They're just different ways of getting there. And they all have different strengths and weaknesses depending upon what exactly it is you're trying to achieve. So the problems you've got to answer here, what is being instantiated? Okay, are you instantiating a class or are you instantiating an instance of a class? How is it being instantiated? Are you using init? Are you using double under new? Are you using a double under copy on a double under call? Are you using a class method? Are you using a class method as a factory? How often is it instantiated? Is it instantiated once per process or once per request? Or both? What's the lifespan of the object? Does it exist for more than one request? And if it does exist for more than one request, how are you dealing with the instance's state? Because what you don't want to have is one person logging in and using your view and leaving some state in that object that the next user then is potentially exposed to. And if you want to avoid all those state problems, and you basically want to say, okay, well, we're going to avoid state by not letting you put anything onto the class object, well, then you're basically telling someone you can have this class object, but the object itself can't have any attributes. So how do you deal with the expectations that users want to be able to put something on self? And then there's configuration. Some of these approaches, particularly using raw class methods, prevent you from passing in arguments. So the old way of doing class-based view, generic views of using the URL pattern and passing in some extra arguments, you can't do using some of these approaches because you haven't got a place you can put in arguments. As a sidebar, it's interesting to note that Django had class-based views a long time before we added class-based views. Django's admin is a class-based view. It uses the call method. Essentially, you have an admin site. The admin site has a call on it, which means it can behave a bit like a function if you pass that information in. There is a single instance of the admin object per process, which means that you can't put anything onto admin as a self. And if you do, you're going to have security problems because you've got leakage between individual requests. Now, it turns out Django's admin, the implementation of it, just passes the request object around and uses the request object for state. But that's kind of an odd thing to do if you actually look into it. And we have had to essentially audit our own code to make sure that we're not accidentally leaking things. The good news is it's not like it's a major security problem because you use the admin, you don't really extend it, and you're always being given the request you need, so the incentive to put things on self isn't there. But as a word to the wise, don't put anything on self if you're customizing your admin because you have potentially exposed yourself to some security issues. So this is, in some respects, an example of why Django needs its own class-based view framework, because we need to be able to make sure when people build their own admins, they don't reproduce the mistakes or the limitations accidentally that we've given them with Django's own admin. So what did we pick? Well, we ultimately ended up picking what many people have called the most complex of all the solutions. We've picked the idea of having a factory class method. So there is a method on the base class view called asView, which returns a function that invokes dispatch on an instance that is instantiated every time the view is called. If you pass in arguments to the view, so we've got asView, template name is food or HTML, that argument is then passed into the init, the keyword arguments to the init method when the instance that's going to have dispatch called on it is invoked. As a result of this, the view's request, the args, the keyword args that are passed in to the view when it's instantiated are stateful, but they have a lifespan that is exactly one request. Every time you visit this view, you get a new instance of this view class, even though you're using a class method to instantiate it. Now, okay, just to sort of fill out why we went that way and not the other way. There's another way we could have gone that many people have said, hey, you should have just done this, it's much easier. We could have avoided all of that complexity about having a class view that instantiates and that whole great big method that Danny showed in his slides. We could have avoided all of that if we'd made one architectural change. We say, okay, at the moment the contract is earls.py must contain a function, or earls.py must point to a function. If we change that to earls.py can contain a function or a class, whole problem goes away. Except the Earls contract at the moment is painfully simple. Callable goes in, it's a callable, the request goes in, the response goes out. Okay, and it's not strictly a function, it's a callable, and that's an important distinction to make, and it's a distinction that admin actually exploits. If it's any more complex than that, then you start having to have these, you start having to put conditional logic all the way through your code, okay? So the simplicity of the contract in earls.py makes a whole bunch of other things possible. If you take out that simplicity and say, well, it could actually be one of two things, you have to, anywhere that you're dealing with a functional a viewer like that, you have to start saying, well, okay, it could be a function or it could be a class, and that class may be a callable, but it may not actually be a view by virtue of being callable. There's a whole bunch of messy logic that you have to reproduce everywhere you start dealing with earls.py. So we made the decision we're going to keep the earls.py contract simple and let the view handle the complexity of how it becomes a callable that can be invoked. It's entirely a value judgment. There was a very long discussion about that value judgment, but that doesn't mean that the other way is wrong. It just means that we decided that we were happier with the trade-offs that we had to make having the complexity in the base view. Okay, so that's the base framework for class-based views. The ravioli criticism is entirely about what comes on top, the generic classes that are being built in that. As a scoping exercise, we set up to say we're going to replace the existing function-based generic views and nothing else. Okay? We're going to do that in a way that exposes all the desirable features of the class-based approach, but not extend any new actual features or capabilities into this space. And the endpoint is essentially a series of mix-ins that can be brought together to build the original generic function-based views. So here we go, a ravioli cooking course. Go back to the original the original stereotypical, here is an edit view method. What we've got is a get object. If it's a post, get the form. If the form is valid, handle it, then redirect. If it wasn't valid, handle the failure. If it wasn't a post, get the form, and then return a response. The mix-in hierarchy for update view contains 9 classes. There is a single object mix-in, which determines how do you get a single object based upon the request, the arguments, and the keyword arguments that have been passed into the view. And that's all it does. How do I get an object? A subclass of that single object or mix-in in there is the context mix-in, which sets up every view that is part of this hierarchy needs to know how to put some basic fields into the context, in particular, the view itself. We have a process form view, and it defines the get, post, and put handling that every update view needs to have. It instantiates a form, but doesn't contain any logic about how you instantiate the form. How does it do that? Well, it instantiates the form by invoking something that's come from the form mix-in. That tells you, the form mix-in describes how you instantiate an individual form, what to do on success, and where to redirect when it is successful, and what to do on failure. You then have a model form mix-in, which is a subclass of the form mix-in, which defines how to instantiate a form when all you have is a model definition. We have a single object template response mix-in, which is given that you know you have a single object in the context, how do I render it using a template? And we have a template response mix-in, which says, given that I know that I've got a context, how do I render it as a template response? Okay, 9 classes. Why on earth would I get involved in that kind of bondage and discipline just so that I can render a form and put it on a page? Well, the reason is because to change that over to a create view, you only need to really change one class. You've just got to move it into a base create view, which slightly changes the logic for how you instantiate the object. Instead of going to the database and instantiating an object, you instantiate an empty object and you pass exactly the same thing through the rest of the chain. Okay, so let's say instead of it being a create, or we want it to be a create view, but we're not going to return a template response, we want to return JSON instead. Well, you just got to change the single object JSON response mix-in. You change that mix-in, all of a sudden the logic that says, how do I produce this response, will start producing JSON instead of producing a rendered template. So, yes, we have a very complex class hierarchy there, and yes, this is essentially where the problem has come from. We need to communicate this. The class hierarchy exists for a reason, and we need to get the message out there that there is a reason, and it can be extended in useful ways. So I'm here to basically to tell you, ravioli tastes good. It allows you to reuse core logic very, very easily. It's extremely flexible for inserting new logic into your class-based views. And it's very easy to add your own mix-ins. In my own project, I've got mix-ins that let you do filtering and search like you do in admin. It's a one-class drop-in and some configuration on any list view, and you get admin-like filtering and search. But you need to understand all the pieces first. The price you pay for tasty ravioli is a learning curve, and the only fix for that is documentation. And to use the technical term, the original documentation was bad. It got all the details correct, but missed the big picture. And Danny's done a lot of work in making that big picture a lot clearer. Sorry? Mark Tamlin, was it? Okay, so Mark Tamlin on the corner as well. We still need some framework level decisions. There are some things that we don't have in the class-based view framework at the moment. Most notably, decorators, and in particular, login required. We haven't really got this is the way you do it nailed down with login required. And at some point, this is really just something where we've got to get the BDFLs in a corner and make a decision. The reason we haven't made a decision is because there's half a dozen ways we might be able to do it, much like the original view discussion, and we just need to pick one and say that's what we're going to adopt as a community. So where to from here? Well, okay, documentation can always improve, and we've got the sprints as an opportunity to do that. There are some BDFL decisions we need to make about how we're going to do decoration as a community, how we're going to advocate for decoration as a community. And we can extend what's there. Like I say, we originally scoped out the class-based generic views specifically to say we're going to replace the functional-based generic views and nothing else. That's as much a making sure we don't just architecture astronaut and go forever and end up never committing anything, given that it had already taken 3 years to get there. So there's a lot of new territory there about things we could add. But before we start charging in and start adding new features, I'd like to pose to the community a question. Have we solved the wrong problem? Cast your mind back 36 slides. I put up this list of features of generic views, and these are all very common problems in 2005. And they're still common problems, but not as common. Modern websites have different problems. You have the problem of having multiple forms and form sets on a page. Admin itself has multiple forms and form sets on a page. The generic class-based views don't currently allow that. The conditional forms, what if you've got a set of options, and if you choose the last option, you need to fill in this extra form. We don't have a good option for that, and we certainly don't have a good option for how you deploy that in a function or in a generic view. What about continuous scrolling instead of doing pagination? List view is great if you want pagination, but it doesn't really help you build anything that's an infinite scroller. And it could, because it's really just a slight change in the type of response that's coming back when you request the next page, which ties into Ajax. We need to be able to do a lot more support for Ajax type things, and including things like in-place editing. PJAX, laying out entire sites, which is all just kind of a generic framework for we have a banner headline on a site and we have a bunch of content under the site. There's a lot of stuff that Django could be doing around supporting PJAX better. And there's the idea of having multiple actions per page. Django's view at the moment is very much, here is a list. It is going to be a list and that's it. You can't do anything else on the page because that's all you'd ever want to do. So how do we merge these multiple actions on an individual rendered page? So here's a call to action. Firstly, if you are discussing these things online, please be very clear about whether you mean class-based views or class-based generic views. One of the things that's very frustrating for me is, as the person who wrote them, is that people come in and say, class-based views suck. Why would you ever want to use a list view? The list view is not a class-based view. It's a class-based generic view. I will totally wear a whole bunch of criticism on the documentation and the discussion about whether a list view is the right thing to do. But that doesn't mean class-based views are bad. I think we've got a very strong framework for class-based views. The documentation obviously can be improved. And there are some relatively low effort wins that we could get to make class-based views more useful. In particular, one ticket that I've got in there, 18830, is an old idea, essentially leveraging what Form Wizard does. Form Wizard will let you put on a page of a wizard a form or a form set, but won't let you put both or multiple forms on a single page. So given that they've got exactly the same contract, it shouldn't be too hard to wrap them, and there's a demo implementation there. And I also would like people to start playing around with APIs, start playing around with experimentations for how we can solve the class-based generic views problem better. I think there's a lot of space, in particular the whole discussion about building a better admin or building admin 2.0. I think we should, if we're going to do that, let's have a think about what the frameworks we're providing, and stop, rather than admin being this once-off bespoke thing that we sell as a great feature, let's eat our own dog food and build a framework that makes it really easy to build admins. I don't know what that looks like. I'm certainly interested in having the discussion about what that looks like, and there have been some people talking about it. So yes, we have the sprints. I'd heartily encourage people to, if you're interested in any of these problems, come and have a talk to me or talk to Danny if you want to talk about the documentation. I'm sure he's enthused to get involved. And from there, any questions?